Hey everyone, I hope you enjoyed your spring break. So, we are going to go ahead and move on to the last unit for 8th grade math, which is made up of two parts. The first part is talking about exponents and the laws of exponents. And those are very important because you're going to use them next year in Math 1 to help you simplify expressions and concepts like polynomials and trinomials and that type of stuff that you haven't learned yet, but you need this foundation, okay? And then the second part that we're going to talk about is understanding how scientific notation works, which is pretty easy once we get the hang of it. So let's go ahead and start off with cluster 6, day 1, and we're just basically going to talk about exponents and the first law of exponents, which is called the product rule. Okay, so before we even get to this product rule, let's talk about what an exponent and a base is. Okay, so in 8th grade, we talk about, um, let me give you an example, like 5 to the power of 2. So basically, the 2, that's the exponent. Okay, and basically, the big 5 down here, we call that the base. And anytime I'm saying, okay, you have a base of 5 or a base of the letter T or a base of, 7, I'm talking about the number at the bottom. If I say you have an exponent of 7, it's this number up here, which is basically stuff that we kind of already know since we were talking about squares and cubes and, 5 to the power of 3 and so on, okay? Now, this is 8th grade because we're going to be talking about product rules just with regular numbers like integers. But in Math 1, you will talk about x to the power of 2. So x is still considered your base, and 2 will still be considered your exponent. But the difference between 8th grade and Math 1 is that instead of having a base that is a number, you're going to be dealing with a base that is a letter, and it could be X, it could be T, it could be G, but it's basically the same idea. You're still going to follow the same rules that I'm going to teach you. But just to help you prepare, I typically do both. I do, either a base of 5 or a base of a number and a base of a letter. And they just go hand in hand. So there's no reason for me to separate them. So I just go ahead and do both, and it's the same thing. Okay, nothing changes. It's not easier. It's not harder, but it helps you prepare a little bit better for Math 1. Okay. So the definition of an exponent is right here. I'm not going to do anything like I'll give you an explanation because we've talked about exponents. Same thing with the base. I gave you examples. Now, you already know that whenever I say exponent of 2, that actually could be called a square. So, 5 square, 7 square, 10 square. We know that when I say 5 square, I'm talking about 5 to the power of 2. Well, what about an exponent of 3? We can call that a cube. So 3 cube, 5 cube. That's basically the same idea as, 5 to the power of 3, which is just 5 cube, okay? Now that we understand the different terminology, let's go ahead and do a couple examples. Understanding exponents. Simplify using one exponent. So the first IXL that you're going to do today is basically these three examples, okay? So all they want me to do is simplify all these numbers as one using one exponent, okay? So let's start with the 42s. So I see how many 42s? 1, 2, 3, 4, 5. So instead of writing 42 out 5 times, I can just say 42 to the power of 5. Okay, and then I'm going to take care of the 51s. So instead of writing 51 twice, I can just say times 51 to the power of 2. So really, my answer could be 42 to the power of 5 times 51 to the power of 2. Okay? And you might say, well, Mr. Numbers, why can't we just go ahead and type it in and give us an answer and get an answer? Well, you could, but they just wanted you to simplify. They just want to make sure you understand how these exponents work, okay? Number 2, same idea. Let's simplify. So I'm going to start with everything that has a 14, and that will be 1, 2, 3, 4, 5, 6, 7. So instead of writing out 14 7 times, I can just say 14 to the power of 7 times, and remember, I can do a little circle for times, okay? Times, let's see how many 2's we have. 1, 2, 3, 4. So we can say times 2 to the power of 4 because there's 4 2's. And of course, I only have 1. So I can just say times 1. Or I can say times 1 to the power of 1. It really wouldn't change the answer, okay? Now let's move on to number 3. Same directions. Instead of writing out 5 3 times, I can say 5 to the power of 3 or 5 cubed times 1 cubed times 3. And remember, I could say 3 to the power of 1, but that really doesn't change because it's implied. So we're just going to leave it like that, okay? Now, the next question under expand, they want us to go ahead and expand 2 to the power of 3 times 10 to the power of 2. Or you can say 2 cubed times 10 squared. Okay, so let's start with the 2 cubed. That tells me I have 3 2's. So I'm going to say 2 times 2 times 2. I'm expanding it, so I'm making sure I get rid of the exponent and just write it out as one big problem. And then 10 squared will mean 10 times 10 twice because the exponent is a 2. And there you go. You have expanded it, okay? So just remember the first IXL is going to be asking you questions like this. They're going to give you a problem like that and they're going to ask you to simplify it, okay? Let's move on to the next page. And we are going to move on to the first law of exponents, which is the product rule, okay? So the product rule is pretty simple. It's pretty straightforward, okay? And let me go ahead and give it to you. At first, you're going to be a little bit confused and you're going to say, I have no idea what that means. But once I start working these problems out, you're going to say, oh, that's pretty easy, okay? So basically, the mathematical rule looks like this, okay? For the product rule. It says A to the power of m times a to the power of n equals a to the power of m plus n. And remember in the past I've told you that mathematicians are sometimes pretty lazy, so they'll find ways to write a whole bunch of information in a simple expression or an equation just to be able to explain what they're trying to say instead of writing sentences on top of sentences. So I know you're looking at this and saying, what does that even mean? Okay, well, let me go ahead and write out an explanation for this, okay? When multiplying the same base, okay, then add the exponents. Okay, so basically this little fancy expression or equation or mathematical statement, what it's saying is that if you're multiplying the same basis, then you can just add the exponents, so that way you don't have to worry about having to multiply all these other numbers and trying to get this final answer. Okay, so let's start with number 1. If you notice, our problem is 3 to the power of 5 times 3 to the power of 16. Instead of me trying to do 3 to the power of 5 times 3 to the power of 16 and get this really big number, I can just go ahead and use my first rule, which is the product rule, and figure out how to simplify that. So my base is 3. And because I'm multiplying the same base, I can add the exponent. So instead of writing out the base 3 twice, I can just write it out as once and take my exponents, 5, and add it with the 16. You see, because we're multiplying the same base, so we're just going to add the exponents. And now, let's do that. Remember, the base 3 just stays there. You don't even mess with it. So 5 plus 16 is 21. So my final answer is 3 to the power of 21. Now remember, this is your final answer because all we're doing is we're trying to make sure that you understand how the product rule works. Okay? You're really going to know how to use the product rule in a couple units, a couple lessons later, and then you're going to apply that product rule on expressions and polynomials when you get to Math 1, which gets a little bit more complicated, but it's not difficult, okay? So right now, all I want to make sure is that you understand that when you're multiplying the same basis, you can add the exponents, okay? So let's move on to the next problem. We have 4 to the power of 11 times 4 to the power of 12. Because my bases are 4 and they're the same and I'm multiplying, I can combine them together by adding my exponents. So 11 plus 12. So that means 11 plus 12 gives me 23. So my final answer would be 4 to the power of 23. Okay? Because I'm using my rule. See, if you multiply the same basis, you can add the exponents. Okay, let's move on. Well, if you notice, we have 10 cubed times 3 squared times 3 to the power of 4. So now, what should I do next? Okay, well, I can clearly combine the two numbers that have the same base, which is 3. So because we're multiplying the same base, I can add the exponent. So I can say 3 to the power of 2 plus 4. Now you might say, well, Mr. Gomez, what about 10 to the power of 3? Well, for right now, let's just bring it down. Okay, let's not even mess with it. So let's write down 3 cubed. Now, clearly, when we add 2 plus 4, we get 3 to the power of 6. Okay, and don't forget your little times. You can either do a little x or you can just do a little dot because those two things mean the same thing, which is multiplying. Now, if you notice, 10 to the power of 3, there's no other number in there that has a base of 10, so we can't even do anything with it, so I'm just going to bring it down. And there's my final answer. 10 to the power of 3 times 3 to the power of 6. Now, I know you're asking, well, Mr. Gomez, why can't we just combine these two and add the exponents? We are multiplying. Well, the problem with that is the base. This is a base of 10 and this is a base of 3. These do not have the same base. So if they don't have the same base, you can't use the product rule, okay? The product rule only works if you have the same bottom number, the same base. You see back over here in problem number 2, my same base was 4. Over here, my base was 3. But over here, the only time I had the same base was right here. That's why I was able to add those two exponents. But with the 10, I can't do anything with it. So this is as the most simplified form I can do, okay? Let's move on to number 6. This time I have letters, and you're going to see it's the same thing. My base is still the same, which is t. So all I can do is I add my exponents, okay? So because I'm multiplying t to the power 4 times t to the power 4, I can just say t. And the exponents can be 4 plus 4, which is basically t to the power of 16. Okay? Or sorry, not 16. I don't know where I got that from. It should be 8. My bad. Ooh. Yeah, it should be 8. So, because you're adding the exponents, so you will get t to the power of 8. There we go. Let me just mark this out so we won't get confused. Sorry about that. I was multiplying the exponents for some reason, and that's a very common mistake, okay? Let's move on to number 7. Once again, I have the same base, which in this situation is the same variable, okay? So instead of leaving it like this, I can just write x to the power of 5 plus 9 because I can add the exponents together. So 5 plus 9 is just 14, so my final answer is x to the power of 14. And then the last problem, we have 3 to the power of 4 times x to the power of 3 times x to the power of 5. So I can start off by combining x to the power of 3 times x to the power of 5. That should give me x to the power of 8. Because when you're multiplying the same base, you can add the exponents. 3 plus 5 is 8. Now, you could leave the 3 to the power of 4 like that, and technically, this is a correct answer. But once again, they said simplify using only one exponent. So in this situation, I'm going to have to simplify 3 to the power of 4 to the point where I'm going to have to evaluate it. So we know that 3 to the power of 4 means 3 times 3 times 3 times 3, 4 times. I'm going to go ahead and tell you if you don't know what that is. That's 81 because 3 times 3 is 9. 3 times 3 is 9. So 9 times 9 is 81. And then, of course, you can bring down your x to the 8th. And there's your final answer, 81x to the 8th. Okay? And basically, the second IXO is going to be asking you questions like number 6 and number 7. And remember, the biggest purpose of this lesson is for you to practice how to use the product rule, okay? If you have any questions, just send me a message, and I will help you, okay?